Imagine looking up at the night sky. You see stars, planets, and perhaps the faint glow of a distant galaxy. Now, imagine one of those tiny points of light suddenly erupting. It becomes brighter than all the other stars in its galaxy combined. For a few brilliant weeks, it shines with the energy of 1 billion suns. This is a supernova, one of the most spectacular and violent events in the entire universe. A supernova is the explosive death of a star. When a massive star runs out of fuel, its own gravity causes it to collapse in on itself. This collapse happens in an instant, triggering a catastrophic rebound explosion that blasts the star's outer layers into space. This single event releases more energy in a moment than our sun will produce in its entire 10 billion year lifetime. But what if we could control such an event? What if human ingenuity could reach out across the stars and deliberately trigger one of these explosions? The idea sounds like science fiction, yet the question lingers in the minds of scientists and storytellers alike. Could we ever learn to harness the power of a dying star? If a supernova were to occur close to us, it would be catastrophic for life on Earth. The blast of high-energy radiation would strip away our planet's protective ozone layer. The idea is no longer confined to novels and films. Theoretical physicists have begun to explore the possibilities, however remote they may be. They ask questions about the mechanics of stellar collapse and whether an external force could push a stable star over the edge into a supernova. Exploring how we might weaponize a supernova forces us to confront difficult questions about our own species. What are the limits of our ambition? There are two main types of supernovas. The first is the Type II supernova, the grand finale reserved for the true giants of the cosmos, stars at least 8 to 10 times more massive than our sun. This fusion process has a fundamental limit. It stops at iron. When the star's core becomes a dense ball of iron, it has reached a dead end. The iron core collapses under its own weight, shrinking from the size of a planet to the size of a city in a fraction of a second, reaching speeds up to 1/4 of the speed of light. The second path is the Type Ia supernova, a tale of two stars. This involves a white dwarf, the collapsed remnant of a sun-like star. If the white dwarf has a close companion star, its gravity can strip matter from its partner, like a cosmic vampire siphoning away its life force. When it reaches the critical mass limit, the entire white dwarf explodes in a thermonuclear firestorm, completely obliterating the star. One hypothetical method involves manipulating the heart of a massive star with a beam of exotic particles, precisely delivering energy to disrupt fusion processes and trigger premature collapse. This approach is like cosmic surgery, or perhaps more accurately, cosmic assassination. It relies on deep understanding of stellar physics and the ability to deliver a targeted strike to a critical weak point. The weapon might be a self-guiding probe or a beam projected from vast distance, traveling for centuries to reach its target and execute its deadly function. Another method focuses on the Type Ia supernova, simply feeding a white dwarf enough material to push it past the critical mass threshold. It's conceptually simpler, a matter of cosmic engineering and heavy lifting on an unbelievable scale. Imagine a fleet of ships designed to mine matter and accelerate it into a continuous stream aimed directly at the target white dwarf. It would be like a cosmic fire hose, steadily dumping mass onto the star's surface. By carefully controlling the rate at which you add mass, you could time the explosion with incredible precision. This transforms the supernova from a random act of nature into a programmable weapon. A supernova is not a precise tool. It's an indiscriminate weapon of immense area of effect. Its primary strategic use would be to deny an enemy access to an entire region of space, permanently and absolutely. The blast would annihilate planets, vaporize fleets, and render that entire sector of space uninhabitable for millions of years. It's a way of saying, if we cannot have this territory, no one can. By triggering a chain of supernovas along their border, an empire could create a wall of death. A vast bubble of lethal radiation that no fleet could cross. The terrifying thing about a supernova weapon is that its effects are not contained. Any star system unlucky enough to be in the vicinity will be affected. Innocent bystanders in a cosmic conflict. A peaceful, pre-industrial civilization might be wiped out by the gamma-ray burst. A young technological society could have its development set back thousands of years as its planet is plunged into an ice age. the use of a supernova weapon would surely be seen as a galactic red line, an act so heinous it would demand a universal response from all advanced species. The energy requirements for any of these scenarios are far beyond anything humanity can currently produce. To manipulate a star, you would need to wield energy on a stellar scale, the realm of a Type 2 civilization. We would need materials that can withstand unimaginable temperatures, propulsion systems that can move planetary masses, and computers capable of modeling stellar dynamics with perfect accuracy. The slightest error could cause the entire project to backfire. Their ultimate weapon becomes their own funeral pyre, a weapon that kills its user. Even if we could engineer a supernova safely and precisely, should we? The power to create or destroy a star forces us to confront the very limits of our wisdom and our moral right to reshape the universe. We are not masters of the cosmos. We are its children, born from the ashes of exploded stars, and we have a duty to protect the cosmic heritage that created us. Our responsibility is to ensure that the night sky remains a source of wonder, not fear. The power to engineer a supernova is a fantasy, but the choice between wonder and domination is very real. We began with the awesome beauty of these cosmic events, the universe's grandest fireworks that seed the cosmos with the elements of life. This exploration has become a thought experiment about the nature of power itself, forcing us to look not at distant aliens, but at a reflection of ourselves. The story of the supernova weapon is not really about stars, it is about us. It reflects our own struggles with power, technology, and our place in the universe. A truly advanced civilization might not be the one that can destroy stars, but the one that understands why it never should. Wisdom, not power, may be the true measure of a species' maturity. So the next time you look up at the stars, consider what our role in that cosmic story should be. Let us hope that if our descendants ever stand before such godlike power, they will have the wisdom to turn away and to leave the stars in peace.